Okay, so my topic for this portfolio is geodesic domes. Through this video, we're going to try and look at the underlying themes associated with it, including the marking scheme that I've created for my assessment question, as well as my learning resource. So what is a geodesic dome? Geodesic domes were invented by Buckminster Fuller in the 1940s. They're a strong structural form which are self-supporting and based on a circumscribing sphere around a polyhedron. The sides of the dome ran up from isosceles triangles, and they were actually invented to improve the housing of humanity at the time, which was going through a crisis. So what will pupils learn from the geodesic domes? They will get an appreciation for the complex geometries and their uses in architecture, the relationship between octahedrons and their circumscribing circles, and they will also learn about self-supporting structures and how objects like eggshells are quite strong due to their physical makeup. Overlapping themes include architecture, engineering, biomedical science, and mathematics. So moving on from this to key principles, students are expected to know about triangles, the division of a line, circles and spherical geometry, as well as the polyhedra. That's just including the 5 regular polyhedrons for this. And then moving on to our learning outcomes, students will be expected to construct the 5 regular polyhedrons, understand and explain faces, vertices and edges, determine the correct usages of strut factors and dome frequencies, circumscribe the regular polyhedra, and construct a geodesic dome with no more than 4 points of frequency. It is important to note that geodesic domes only come up on the higher level side of the syllabus. Okay, so this is my first learning resource. It's a foam football. It's been cut in half. It'll show students just a basic guideline of how geodesic domes are made, so you can see the main shapes of a hexagon, a pentagon, and the triangles it's made up of. As well as that, students will get a real life sense of football. They should know what football is, and that will relate to their real life experience. Okay, so this is my second learning resource. It's a cardboard model of a geodesic dome, and through this, students will be able to visualize the makeup of the geodesic dome and how the strut factor affects its form. With accompanying triangles, students can explore the shape of the form. So here are the triangles below. Depending on the class, I would encourage the students to develop their own dome while allocating a group to ignore strut factor as a control group. So Dan, looking at the geodesic dome, what would you take from it?
So one of the main things that I took from it is how I can place this triangle here, the CCB, up like this on the hexagon, and similarly on the pentagon I can place it like this, which shows how they merge onto each other, but also how different lengths are obvious due to the strut factors, and how the model highlights the ways in which the polygons protrude and give the dome shape that's seen above.
Yeah, that's perfect, Dan. And as well as that, just looking at this dome, we can apply a weight to the top of it, just to show that it actually holds quite a substantial weight for its size. Perfect. Okay, so here we can see my assessment question for my peer on geodesic domes. Through the question, students will be asked how to construct the elevation of an octahedron and how to draw a 3-frequency geodesic dome. This question is designed to assess the students' understanding of geodesic dome and their ability to manipulate 3D objects through space. I feel the marking scheme provided as well is fair, and it assesses the important areas to which geodesic domes relate. Dan has already completed the question. So Dan, what did you find beneficial from this?
So from doing the question, I've combined my knowledge from other areas, such as polyhedra and manipulated projections, to give me a comprehensive judgment of my ability to complete questions surrounding structural forms.
Perfect. So we look here at the marking scheme. We can see that very little marks are actually going for the completed plan of the geodesic dome. I felt this is important to include, as it is not actually important for the student to be able to complete the full dome, but if they could complete a portion of the dome, it would show all the required geometries, as I would be able to expect them to rotate the points around the central axis. As well as this, you can see there's quite a few points going for the actual formation of that section of the dome. And as long as they can accurately form that dome, I feel as though they have met the requirements needed for this question. There's less marks going for the completion of the octahedron, as this is referring back to previously covered topics and isn't exactly what we're examining here.